Hey guys, what's up? Welcome back to a video, and today, very exciting, we're doing an X-Class build. So since I really have no experience with not only building an X-Class in general, but also with this frame, these electronics, this build isn't going to be too in-depth of a build video, because normally with my 5-inch quads, I know exactly what I'm doing, so I'm very confident when I'm showing it to you guys. However, for this, it's going to be a complete learning experience for me. So a lot of it will be done off camera, and then I'll come back and explain what I've done and try to show you up close then. Especially since this thing's just going to be so big, it's really not going to fit on this bench. And with the size of this stuff and these wires, it is going to need a lot of heat. So it's probably going to take a long time and wouldn't be any fun to actually watch the soldering. So as you guys probably saw, I did fly an X-Class a while ago, the Catalyst Machine Works Cannonball 800 with the polar motors, etc. on 12S. That is not mine, that was my friend Tiny's LEDs. He let me fly it for a video, so thank you very much for that. But now this one is going to be my own one, and this one is actually going to run on 8S, not 12S, because of the iFlight electronics here. These are all iFlight. So let's just real quick start with the frame. Here are the arms here. They just come in these carbon tubes. This is their, I believe it's the IX15 frame. It's 950 millimeters. I'm not going to go too in-depth in it because a lot of the specifications are listed on the site. But just showing you what you get. You get the battery pad, you get 3 battery straps, couple 3D printed mounts, some stickers, and a bunch of very long screws and hardware. Obviously these carbon tubes, and then all these other plates that go into mounting the motors, and then the arms to this center section. Now, a few things about the frame. I am a little bit skeptical comparing them to the Catalyst Machine Works Cannonball right here. Hopefully you can see these arms are pretty big. I don't really know if you can tell the scale by this. They're definitely a lot smaller. These Cannonball arms are sort of an octagonal shape, and they look like very nice high quality carbon. This is a very heavy duty frame. So looking at the iFlight, it seems like a much lighter design in general, and it definitely is cheaper. The Catalyst Machine Works frame is $450 just for the frame. This iFlight one is $180. So it'll be interesting to see how cheap and how light it is, and how it compares, since this will be only flown on 8S. For the motors, we have these monsters here, the iFlight X-ing. Really cool to see them make their X-ing motor line in this giant size. They're 4214, 400 kV. Once again, they run on 8S. Really nice, solid, hollow titanium shaft. We have a screw for the bottom. Lots of material on the base. There was a problem with the polar motors. I actually broke one of them. They broke off at the base, so it's really nice to see all this extra material. Do have, it looks like multi-stranded windings. Do have adapters for T-mount props as well. Serrated top, very nice motors, and hopefully you can tell these things come with a lot of wires. I have them hanging off the table here. Like, they have over 2 feet of 14 gauge wire on them, so it's nice you don't have to extend them. And then might as well, real quick, just go ahead and weigh this. There's not even really any room. I have to do it over the side, but I have this one sort of wound up here just to try and see how much it weighs. That's 262 grams. I know you can't see it, I'll just have to trust me. But all this is 262 grams. This thing by itself, if you throw it in the air, the FAA is going to come after you. This thing's not even legal to throw in the air by itself. Moving on over, we have this little iFlight PDB, and I'm actually a little bit worried about this. It says on the back that I can handle 330 amps, but it doesn't look that beefy. It looks like something you'd use in a 5-inch quad. So especially going to be trying to solder 10 or 8 gauge wire to these pads is going to probably be pretty difficult. If you look here, let me get one of these wires. Once again, this is 14 gauge, and this fits the pad pretty well. So imagine trying to solder 8 gauge to this. It is not going to fit. So it's going to be very interesting trying to use this, but they say I can handle it, so might as well try it. For the flight controller, we have the new iFlight Dual F4 Twin. I think you can see here it has 2 MPU 6000 gyros, if I'm not mistaken. So I think that's supposed to do something. I don't know, maybe do something filtering, but we're going to try this guy out. Looks okay. And then for the ESCs, we have the iFlight Sussex 80 amp ESC. I don't even think these are on their website yet. Definitely a very small ESC to be claiming 80 amps. Here's a DYS Aria I have that says 35 amps. So it'll definitely be very interesting to see how these handle. Should probably put a heatsink and a capacitor on these as well. but we'll have to see. So yeah, that was just a real quick overview. I'm not sure what video transmitter and receiver I'm going to be using yet. Probably a TBS V3 and probably a Crossfire Nano. I'm just going to stick there on somewhere and probably use a Micro Predator or something for the camera. But this is the stuff that really matters: the frame, motors, and ESC, and flight control and power distribution board. This is the real stuff that matters, that differs from 5-inch quads. This thing's going to be insane. So once again, I'm not really going to be able to show too much of the build because it's going to be a first for me. I have no idea what I'm doing. There's a lot of parts of this frame, but they do give you a little exploded view here, so that should definitely help. And if you're curious for batteries, what I'm going to be running, these are just two 4S4000s I'm going to run in series to make an 8S4000. I also have just ordered two 4S5500 batteries, so it'll be a 5500 8S instead of a 4000 8S. I think that'll probably work better for racing, and this can be more of acro since this should be a little bit lighter of a setup. So let me start putting things together, and I'll come back when I'm able to figure something out. So yeah, let's do that. Alright, so here we are. I have been working on this frame for almost 2 hours now, just assembling the arms here. I just finished the first 3, and as you can see, they sort of use this interlocking design. And when I did this first arm, it took me an hour because I put everything in the wrong spot, in the wrong order. So yeah, I'm going to show you how to do the last one while I work on the last arm there. So it is definitely worth paying attention if you're building this and do it in the exact same order I do, because it's taken me a long time to figure out exactly how to put this together, because there's a lot of small things you learn putting 3 of these together. Okay, so first we need the arm. We need the side with the small M2 holes. The other side has larger, I think they're M4 holes. Actually, these are M3. I think these are M4 or 5. So we need this. Then we need our motor mount piece, and this is important. It does come with 2 different sizes. You can see this is the smaller size. This will not fit the X-Wing motors. Found that out after I assembled the entire thing. You need this larger one. You can see it sort of has these extra cutouts. This one does not. So you need to use this larger version. First up, I'm going to take one of the M3x6 screws, and I'm going to use Loctite on every single screw in this build that does not have a nylon lock nut. So I'm just using some blue Loctite on these. I'm going to put this through the plate, and then you're going to take one of these small, I believe, 10 or 15 millimeter standoffs and screw that on. Okay, so that's the first important step. Make sure you put this standoff on. Next, for the motors, they use these massive 3 millimeter screws. I had to go find a 3 millimeter hex key. So once again, you're going to use some Loctite. And you need to screw the motor on backwards with the wires facing towards that standoff you just put. If you're not using Loctite on everything, I at least highly recommend using Loctite on your motors. It's a very expensive quad, potentially a very dangerous quad. That's not the right screw. Potentially a very dangerous quad. You do not want things vibrating, and you do not want things falling off mid-flight, so just bite the bullet, get some Loctite, and put it on everything. Alright, those are in. Now I'm going to use the hex key to tighten them down all the way. I'm going to use alongside. Give them a good torque. It's a very beefy motor, very beefy screw. You probably won't strip it. Don't go crazy, obviously, but make these pretty tight. It's going to have a lot of power, a lot of thrust. Don't want it coming loose. Okay, so there is that. Next, we are going to take these very long motor wires. It's kind of awkward to do in front of the camera. And we are going to thread. Okay, so now for this, I'm going to fold the motor back up and just hold this in place. A little awkward real quick, but you kind of just have to hold it. And then I'm going to go ahead and grab these M3 by 30 millimeter screws. Some of these holes have been a little tight like this one, so you kind of have to, there we go, get it started a little bit and then press it through with the driver while slightly turning it. Right, there's that. And then we're going to take this bottom piece, and that's going to go right over those screws. Should press over, and then we're going to take 2 of the lock nuts and put these on. You want to put these decently tight for right now, but don't crank them all the way down because you still need to slot some other pieces in. Just wiggle your wires around, make sure nothing is getting pulled awkwardly. And then we can go ahead and get our side pieces, which look like this. And hopefully you can see these two screw holes are offset a little bit towards the end here. Order, you're going to take another M3 screw, another standoff, put this through here, and screw this guy onto that, tighten that up. And then we can go ahead and put this through. You can see it sort of goes behind this one. And then we're just going to go ahead and line up all these slots that we have so far. See, there we go, everything snapping in nice and tight. I probably put mine a little bit too tight, but there we go. And there's the last one in. So now first what I like to do is take the other M3x30 screw and insert it into the side closer towards the body. Wiggle it, make sure it's not pinching any of the wires in there. Then you're going to take your last hex nut, and that just screws all the way through there. And then at this point, you are able to fully tighten this down. Let's go ahead and crank that pretty good. You don't want to strip out the lock nut though. It's just going to get a little wiggle room on our wires here. I'm going to, while I have it, crank down these other two lock nuts from before. And then lastly, I'm going to take our last two screws for those standoffs we pre-inserted, and I'm going to put a little Loctite on these and just screw them in. One for the side standoff. Then I'm going to put our very last screw in. And there we go. A motor, full arm, built in 9 minutes. Definitely a lot faster than an hour. So there we go. Have all 4 of the motors screwed onto the arms. And just a quick note, there is holes in the bottom here for your driver to go in, and you can loosen and tighten those screws. However, if you already have this thing built, the screw head actually doesn't fit through here. You can loosen it with the driver, but the head of the screw won't fit through here. So doing it in the order that I showed you is pretty important, and it'll make it go a lot easier if you do that. So let me go ahead and try to figure out how the heck it assembles to the body base plate here. I'll probably do the 3 arms again and show you the last one just so I can figure out what's going on. So yep, let's cut to that. Okay, so as you can probably tell, there has been quite a bit of work done, and as I mentioned earlier, a lot of this is going to be off camera because I just have absolutely no idea how I'm going to put this together, and this is like the 4th revision of what I've done, so there's no point in me really filming it. I'm just kind of doing an overview after I do it to show you exactly what I did. So firstly, as I put a text thing on the screen, let me flip this guy over. Instead of going down through the arms, I routed them around down underneath. And the reason for that, if you look at it, if you look at the center body plate with the board on there, there's absolutely no room for any electronics other than the flight controller and PDB in there. There's no room for the ESCs. So it's definitely a very tight center section of the frame. And just real quick, I do know that is the top plate. I just have the arms held on here just to sort of hold things in place and see where they're going. This is the bottom plate, I do know that. I have to take this out anyways to, when I put this on with the other braces, this will be the bottom plate, such as that. So as you can see, I ran the wires down underneath and then routed them up to the ESCs here. I can't really show it because the camera, I can't turn it any farther than this, but I put the ESCs here, and this is actually a 3D printed holder that I designed. It took me a couple tries to get it right. But the ESC actually sits down in it. I put a little bit of tape under the ESC because it's a little uneven, so I put some tape there to help even it out. That goes under. There's these 2 little lips that go over the sides. You can see there's room for the 3 wires here, and then there's lips for 2 zip ties. And you have your power out the other end. So this will hold it nice and tight to the arm and leave this top section free, because actually I'm going to put some heat sinks here. I just don't have them yet. So I'm going to put some heat sinks on the FETs. So this 3D printed file I've already uploaded to Thingiverse. If you're building this or using these ESCs, you're more than welcome to download and use that if you'd like. For the power wires, I'm using 14 gauge, the same wire on the motors, because it's only a couple inches to the flight controller here. Could use 12 gauge and then 10 gauge or 8 gauge for the battery, but I think 14 will be okay going a short distance. They use 14 on the motors because it has to go this whole foot and a half distance on the arm, and the longer the wire, that's where gauge matters more. If you have short things, it's not too big a deal. These ESCs don't have a ground pad for the signal, so I just took the signal and wrapped it around the ground wire in an attempt to reduce some of the noise. And I will be adding some capacitors, some 50 volt 560 microfarad caps on. I don't have them currently, but I will be adding them. I'll probably just put them somewhere around here. Because these brace pieces here do go on these sides yet underneath these wires, so have to keep that in mind. If we come into the center and take a look, I'll take the flight controller off. This just slides onto the gummies. I just put some metal screws all the way up through, and then there's the PDB. I'm a little bit worried about this guy once again, just so much power coursing through this $17 board. It's not that confidence instilling when the APD board is like $75, $80, but we'll see how it goes. And then it just has this little plug for the flight controller, so that should actually be pretty much it. That should be wired up for that. In this first run edition of this quad, I'm not going to be adding any of the LEDs or FPV gear. Just in case it crashes and burns and just explodes all over the field, might as well not waste the time making that all pretty and the money if it breaks anything. So I'm going to see if I can get it working here, just line of sight first, and then I'll go ahead and add the FPV gear and LEDs everywhere, all over the arms. This thing's going to be amazing with the tiny LEDs, X-Class LEDs. Going to be running on 5 volt RGB, I think. Going to cover the arms in them. And yeah, actually, now that I realize that I'm not adding FPV to this, this is almost good to go for line of sight. All I need to add is the crossfire receiver somewhere in here. But I need to go ahead and wait. I'm waiting on the battery leads and the capacitors and the heat sinks, and a couple other small things for this, the battery plugs, etc. So I'll try to film something of that. Once again, I know I haven't filmed too much on this, but it's just sort of an overview. And this thing has taken, I've already built for like 20 hours straight getting this thing to where it is. This definitely takes a lot of time and effort to build something this big. As well as you can tell, not even close to fitting on camera, so there's not a ton of point in doing that. So yeah, I'll come back with an update with my next progress. Alright, so I've gone ahead and got a few more parts in the mail, made some progress on the build, so real quick. So as you can hopefully see on the ESCs, I got my capacitors now, and now these are some Panasonic 50 volt 470 microfarad capacitors. I'll link them in the description. Got these from Arrow, very nice cheap price, they're like 25 cents each, very quick shipping. Put those on the ESCs. And then I also put a 560 microfarad 50 volt capacitor on the main battery pads, as well as I soldered on the leads. And now this is 10 gauge wire hooked up to AS150 connectors. And if I show you, this is the tip that I'm using on my iron here. Hopefully you can show it's a little beat up. Been using it quite a lot so far, but it's a very large chisel tip, and I've been using it about 450 degrees Celsius, and it's plowed through this 10 gauge wire absolutely no problems. So I was a little bit worried about wiring the large wires like 10 gauge like this at first, but with the new iron tip on there, very, very big difference, and it was able to solder very well. For the flight controller, I thought I had a few issues, but I got some new CLI commands for this F4 Twin G version. I'm not sure why it wasn't working at first, but iFlight sent me some things to put in the CLI, and now it's working just fine. I got it set up. I put the crossfire here on the UART 6. They show this installation on their website for the Crossfire Nano, so very easy how to hook that up. And then for the antenna right now, you can see I just put it through the hole in the top plate and hot glued it, so it's going to stick out the sides, something like this. Not the best long range, but there's no way this is going to cause a problem. It's more concealed on my 5-inch quads. There's plenty of free antenna, and I always have like 99 link quality anyways, so it should be very durable there. And then that's pretty much it. The flight controller just plugs straight into the PDB, and once again, I won't be adding the camera or VTX for right now, but I'll have to fit those in there somewhere. I was a little bit worried since the flight controller does technically say 2 to 6S on their website. However, they confirmed that they have made a new version. It does say 36 volts. Should be able to run on full 8S battery voltage. I plugged it in, spun the motor, set it up in beta flight. Everything's looking okay so far. I'm just a little bit worried, but hopefully the 4 capacitors in the ESCs, pretty big capacitors for the ESCs, and the big one on the battery lead will definitely help. As for the batteries, I just put the AS150s on these two 4S4000 packs here. And now I have 5500s coming as well, but these are just sort of my backup for right now. So let me go ahead and show you plugging it in. Just for the series, obviously, you plug the two centers together, and then you plug your negative in, and then your positive. And these AS150s have a little spark resistant thing in there. Oops. A little resistor in there to prevent sparks, so when you plug it in, everything is nice and smooth. Not sure why that flight controller took so long to boot up, but everything sounds good there. So yeah, really, now I just have to go ahead and put this heat shrink over the receiver and push that in there somewhere, and then screw on the top plate as well as the little side pieces and the front camera cage. And I'll show you that. I'll probably actually finish up this video outside so I can pull the camera back a little bit further, because there's just absolutely no room here on my bench. Alright, so here we are to finish up the build overview of this X-Class quad. So let me go ahead and just overview what I've done from the last little clip. As you can see, I put the top plate on correctly with all the side pieces here, the sandwiched arms, as well as this front camera cage. And I'm not sure if I don't think I put it together wrong. It just, the cage didn't really fit. I don't know if you can see. It's almost like it had to squeeze it a little bit. I had to really press it in there and sort of hammer it in with my screwdriver to get these pieces to fit together. So I'm not sure if it was just slightly measured or cut wrong, but I had a really hard time getting that together. But once it fit, it's going to be super sturdy, and the GoPro Session can sit right on there at a 30-degree angle, and as well as that should be pretty durable up in the front. Hopefully you can see I added some heat sinks to the ESCs here, and let me set this guy down for applying that. I used this MG Chemicals thermally conductive adhesive. This is from Amazon. It's like 20 bucks to, you have the resin and the hardener. You put this out onto I used a paper plate and mixed it with a toothpick, put some on the fets, just a tiny little bit, squeeze the heat sink on, it should cure in a few hours. You can see I have installed also the 470 microfarad 50 volt capacitors to the ESCs, as well as, if I can get it in shot here, in the back I put a 560 on the main leads. Underneath for the battery here, I just put some of, can't really show it, hopefully you can see that black stuff in the middle here. The iFlight does come with its own battery pad, just cut it up into a couple squares to put the batteries on. These are two Genzace 5500 4S that will be run in series to make 8S. As well as you can see I swapped the connectors to the AS150s here to make it nice and easy to plug in. These battery straps, got these from Amazon, they're 350 millimeters. The way I built it, you can run one through the middle, hopefully you can see under the power distribution board. However, with these batteries, they're actually too short. You need 400 millimeter ones for that. So the ones I ordered do not fit. When I was using these 4000 4S batteries, they're a little bit longer and definitely a lot skinnier. I was able to fit a 350 around, but with these thicker 5500s, you need at least a 400 to go around the center, and the 350s barely make it around the front and back. Where I actually strapped it, hopefully you can see it, it's sort of behind the camera cage here, and then in the back there's a little spot. See if I can get it to show, hopefully you can see this carbon piece. There's a little spot for the battery strap to go right over the back. And now real quick, just to talk about these propellers, these are some random, really old carbon 12x6 plane propellers for an airplane that I found. The only reason I have these on is because I wanted to test fly this guy. If you follow me on Instagram, you probably see this flying around just a little bit. But these are definitely very underpowered for this. And here is a propeller that you'd probably be using. This is a Master Air Screw 13x12, so 13 inches instead of 12, and 12 inches pitch instead of 6-inch pitch. So if I scoot this back, as well as obviously it's a tri-blade, so I put that on there. You can see it's quite a much bigger, much meatier prop for this. Just a quick note about the weight, as is with the 5500 8S battery on there. The two batteries combined into one. It weighs about 6.5 pounds right now, so that is still missing the camera and the video transmitter, the FPV system, as well as I will be putting a whole bunch of LEDs all over this. But it should still stay under 7.5 pounds, which is actually pretty light compared to the other X-Class build that I've flown. So it'll be interesting to see how the lighter setup compares overall, even though it is using smaller motors and cheaper electronics. But yeah, that's pretty much going to be it for this little build overview of my X-Class quad. Sorry I couldn't show too much, but it was a huge learning experience for me. I would definitely build it differently. If I build a second time, for example, I'd build the center section first and then work my way out to the arms. It was pretty difficult to work on the bench with it being so big, everything in the way. In terms of the frame, just real quick, I know a lot of people on Instagram are asking me about like how stiff the frame is. For what it is, it's only $180. And for how large it is and how small it is, it's very stiff. It's not as stiff, and it definitely, I would say, definitely not going to be as durable as something like the Catalyst Machine Works Cannonball 800. But that's a totally different class of quad in my mind. If you build that frame, that's a $450 frame. This is $180. It's half the price. So if you're building a Catalyst Machine Works, you're probably going with the Polar motors from MAD and 12S and APD electronics. So it's probably going to be like a $1,500 quad versus this one's around $500, $600. So this is definitely a lot more budget route, something that a lot more people will be able to consider versus the $1,500 quad, which is really limited. You got to be really committed to spend that much money. So yeah, that's pretty much going to bring us to the end of the video here. I can't wait to really get this thing flying. Once I get some more props, don't have enough to make a full set of these right now. A couple of them are broken. I just had this one on hand. I have a couple more coming. And I can replace these really underpowered plane props. But yeah, all the parts will be linked down in the description below. From iFlight, thank you for sending these parts to test out. I can't wait to get the props and start tuning this thing and just shredding it line of sight and taking it to MultiGP International Open and seeing how it goes in an actual race. So yep, links down in the description below. Thank you for watching. Please subscribe, and I'll see you in the next video. Bye.